Microplastics are everywhere, and turns out they're swirling around in our atmosphere too, being swept up to great heights, traveling with the wind, and raining back down on Earth. And now an international team of scientists have figured out where they're coming from, and the places are probably not what you'd expect. But how does all this plastic in the air affect our health? Let's start with the basics. Microplastics are tiny specks of plastic less than 5 millimeters long. Think anything shorter than the width of a pencil eraser. They come in two main categories. The first type is known as primary, which are already small plastics like glitter and are directly released into the environment. The other type is secondary microplastics, which form when larger plastics degrade. Most plastics are broken down through weathering, like when they're exposed to waves, wind abrasion, and UV radiation. And depending on the type of plastic, it can take up to hundreds of years to break down, if at all. And because microplastics are so tiny and lightweight, they can be transported over long distances globally.
We were really interested in first understanding how much plastic is being deposited, but then we wanted to ask, where is it coming from? How long can it stay in the atmosphere? And how is it getting into the atmosphere to begin with?
So Dr. Brainy and her colleagues tackled those questions using atmospheric transport modeling and data from sampling sites in the western United States.
We estimated that somewhere between 1,000 and 4,000 tons of microplastics are being deposited into western protected areas. And this is equivalent to about 100 million to 400 million plastic bottles every single year.
The team found that 84% of those microplastics likely originated from roads, with the rest coming from oceans and agricultural dust. So why are we seeing so much microplastic coming from roads? Well, roads and the cars that drive on them provide the mechanical energy needed to make plastic airborne. As you're racing down the highway, tiny bits of tire and other microplastics stuck to your tire fling off and fly away.
So I think of it much like the way people move sand away from a beach. Cars can move plastic away from cities and then also move those plastics high into the atmosphere.
We're already seeing the negative effects of microplastic pollution. Limited research has also revealed that microplastics affect the health of plants and animals, which has impacts on the entire food chain. And as microplastics clutter our land, waterways, and atmosphere in higher concentrations, we'll have to monitor if and how they might change atmospheric processes too. There's also the unsettling potential of how they could be affecting us. Some of these microplastics are small enough to be inhaled into the human pulmonary system. Once these tiny plastics get into the body, they can have quite a big number of effects. Some larger microplastics can be filtered out of our respiratory system when we cough, sneeze, or blow our nose. But limited research suggests that smaller microplastics can reach and remain in the respiratory system. And continued exposure to plastic, like when you're working in a synthetic fiber factory, can lead to inflammation, lesions, and respiratory conditions. Unfortunately, though, we don't have enough info on how everyday exposure to plastics affects us, i.e., not in a plastic factory. So some scientists are trying to find out more. In 2019, an international team of scientists used dummies to mimic the inhalation of microplastics indoors. The study found microplastics in every sample of air. A more recently published study from Florida State University focused on the impacts of microplastic exposure on the cellular level. After exposing human lung cells to polystyrene microplastic spheres, the team saw their metabolic processes slow down and rings of microplastics form around the nuclei. But none of the cells died. These studies are still very limited, but they are getting us closer to understanding how the accumulation of plastics in our environment, particularly our atmosphere, is affecting human health. What we know for sure is that if our plastic production and consumption continues to grow in the coming decades, as expected, plastic pollution will increase too. And we're just starting to understand what those impacts will be.
I think we can't ever begin to start mitigating an issue until we really understand it. So understanding not only how plastics are being deposited and moving through the atmosphere, but how they're getting into the atmosphere is really critical for us mitigating the amount of plastics that are emitted.
If you want to learn more about the creative ways scientists are combating COVID's plastic problem, check out that video here. Let us know in the comments what else you want to know about microplastics. Make sure to subscribe to Seeker for more groundbreaking science news. Thank you so much for watching, and I'll see you next time on Seeker.